Today's video is about slope. So many of you have probably heard of slope, and you most likely heard it described as rise over run. So just so you know, the rise means the amount you go up or down. Or the amount the line goes up or down. And the run is the amount the line goes left and right. That's when you're looking at a graph. We're also going to talk about a little bit having to do with the rate of change. I'm actually going to only do that with the honors, but if you're in CP, you can feel free to watch that part of the movie too. So one way that we describe slope is rise over run. Another one we call it the change in y over the change in x. One way that you'll see it when you get into higher level classes, you don't need to know this now, but I'll just point it out to you. Sometimes you'll see it used with a little triangle that's actually not a triangle, but the Greek letter delta. So it'll be delta y over delta x. So delta, like I said, it's a Greek letter, and it means change in. So delta means change, so sometimes you'll see that too. And another thing to know is that slope is actually, we use the letter m for it. So our general formula for slope overall, we're going to use m equals y2 minus y1 over x2 minus x1. So this is going to give you the slope between 2 points and the 2 points I'm going to call x1, y1 and x2, y2. So that's going to be our formula for slope. Make sure that you know that one. You do need to have that memorized. If you want to remember it as rise over run or change in y over change in x, that's fine too. It's important that you're able to recognize different slopes. So you can see here that the positive slope is one that goes from down to up, from left to right, so it rises from left to right. The negative goes down from left to right, it falls from left to right. Zero slope is just a straight horizontal line. An undefined slope is a straight vertical line. So it's important that you're able to recognize those, because if you have a graph and you need to find the slope, you'll know right away if you made a mistake, if you get something that doesn't fit that. So let's go into some examples. And what I'm going to do for these examples, I'm going to give you 2 points, and we're going to find the slope of the line between them. So, first thing that we have 2 points. If you want, you can always draw a line through them to see what they look like and at least tell if they're going to be positive or negative. However, you don't need to do that because we have that helpful formula. So, our formula is y2 minus y1 over x2 minus x1. I usually, when I first learned this, I like to start out by writing x1 and y1 and x2 and y2 for every single one. Just make sure that you keep the x1 with the y1 and you keep the x2 with the y2. That's the important thing on this one. So, actually, the biggest mistake I see is people take the first point, they put x1, x2, they take the second point and put y1, y2, they get the entire problem wrong. So just be careful. One other thing to note is that it doesn't matter what point you label as x1 and y1 and what point you label as x2 and y2, it does not really matter. As long as the x1 and the y1 go together and the x2 and the y2 go together. So all you do from here is you take your formula, you're going to substitute in the numbers that you have. Be careful with those negatives. I see a lot of people making mistakes on those. So when you work this one out, you will end up getting 2 over positive 6, which gives you 1/3. That's our answer for number 1. For this next set, I want you to try it on your own. There might be 1 or 2 that have a little trick with them, but just give them a try, see if you can get it using the formula. So, I'm going to write down my formula. You probably already have it on your paper, so you don't need to rewrite it. And we're going to just go ahead and substitute in the numbers. By the way, if you use a different x1 and y1 from me, like if you started off and you called the -7, -1 the x1 and y1, that's fine. You'll get the same answer in the end, as long as you didn't make a mistake. So we're going to go ahead and work this out. And your final answer, you get -6 over -1. Make sure that you reduce, and your answer for that one will be 6. So notice how on numbers 3 and 4, there's some weird things going on even before you look at them. You'll notice that with 3, you have the same y value, and with 4, you have the same x value. Whenever you see that, I want you to keep in your mind that something strange is going to happen. Be careful about that, because sometimes people make easy mistakes on this that they can avoid just by looking at the problem. So this one, we're going to do the same thing. I'm not going to write the x1 and y1 and x2 and y2, but you can if you want. You'll get 2 minus 2 over 4 minus 5. Now 2 minus 2 is 0. And we have 0 over -1 just gives us 0. So that's a 0 slope. You'll find that if you were to graph the 2 points, it would be a horizontal line also. So then the next one, we have 1 minus 2 over -3 minus -3. Be really careful about that. The number one mistake I see people making is they just write it as -3 minus 3 and they get it wrong. So we get -1 over 0. And -1 over 0, if you remember our number one rule of math, you are not allowed to divide by 0. You're not allowed to have a 0 denominator. So what we're going to do for this one, we have 2 ways to write it. You can either write undefined, or if you're a little lazy, you don't like big words like that, you're not very good at spelling, you can feel free to just write a 0 with a line through it. This is a special type of problem that involves a little bit more work than the previous ones. So we're going to find x, and we know that the slope between x, 4 and 6, -1 is going to be 5 over 6. So what I'm going to do, I'm going to still use my formula that I had before. Whenever you're asked to find the slope, this is always going to be the formula that you use if you have 2 points. So this x, I'm going to refer to that as my x1. The 4 is going to be my, oops, I made a mistake. 4 is going to be my y1. And I'm going to write the 6 as x2 and the -1 is y2. So then I'm going to substitute those in. I get -1 minus 4 over 6 minus x. So that would be what my slope is. It any way that you possibly can. But unfortunately, you'll find the only way that you can really do that is you can write the -1 minus 4 as -5. So now you need to use the other piece of information that you have. You know that the slope between those 2 points is 5 over 6. So I'm going to use that as my m. So what I'm going to do is I'm going to take that, and that is going to be equal to the thing that I just calculated. So take a look at this problem. See if you can think of any possible way to solve it that you've done before. So if you thought of using proportions, very good. That's how you're going to do it. So let's go ahead and do it. I'm going to start with -5 times 6. I know that that's -30. Put my equal sign in the middle. 5 times the quantity, 6 minus x. I'm just going to use the distributive property for that and then solve it from there. So when you do that, you get 30 minus 5x equals -30. And once again, you're going to just continue using what you know about equations. You get -5x equals -60. If you divide both sides by 5, -5, you will get x equals positive 12. And that's my answer. So the next section is for honors only. So if you're not in the honors class, you don't need to do it. However, if you do, it certainly will not hurt you. So this part is on the rate of change. So the rate of change is an example of a ratio which compares two quantities to each other. Some examples of rates of change are miles per hour. When you're driving, that would be, the speed would be miles per hour. If you work a job and you make like $15 per hour, that's actually another rate of change. That means the more hours you work, the more money you're going to make. So there's a lot of different things that you can use with rate of change. You'll actually see it a lot in your science classes also, and in future math classes. So one thing I want you to remember is the steeper, when we're working with rate of change, it actually has to do with slopes, and the steeper the line is, the higher its rate of change. So that's if you're looking at a graph. The steeper your line is, the higher its rate of change is going to be. We're going to do a problem from the book. It's actually on page 179. And there's a few other problems there if you want to practice doing a little bit more, but we will do some in class also. For this problem, I want you to take a minute, read through it, and look at the graph. So for this one, they're asking you about rate of change. And if you remember, in the very beginning of this lesson, I told you a few definitions of slope. One of the ones I gave you was the change in y over the change in x. Now, we actually use the same exact formula for rate of change. The one difference is that with these rate of change problems, they will usually give you a situation. And we actually have a situation here. They're talking about the change in temperature over time. So what we're going to do is we're going to, instead of writing it as change in y over change in x, we're going to write it using this context that they give us. So they tell us, if you look at the y-axis, they give us that the y represents temperature. So I'm going to rewrite that as change in temperature instead of just change in y. For the change in x, I can actually write that as change in time. The other thing that this helps us with is that this is going to tell us what our units are going to be in the end. So we know that the top part of this is going to be temperature. The bottom part of this fraction is going to be time. And they tell us it's actually going to be degrees Fahrenheit for temperature. That's the given units. And it's going to be hours for the change in time. So what we're going to do is we're going to write that as degrees Fahrenheit per hour. That will be our units for this problem. So we'll go ahead and try this now. If you look at the first one, we want to find the time interval when the temperature showed the greatest rate of change. And if you look right up here at my definition, I told you that the steeper the line, the higher its rate of change. So if you look at that line, you'll see that the highest rate of change occurred between 0 and 1.5 hours. That's actually a perfect answer to the question that the book asks you. However, I'm actually going to ask you to go a little bit further. So I do want you to tell me between 0 and 1.5 hours. I also want you to take those points that they give me and actually find that rate of change. So we're going to use the 2 points that they give us where we see that on the graph. So we see that it happens between 0 to 50 and 1.5, 1,000. So we're going to use those and find the slope between those 2 points. And we just use the formula like we did before. The only difference is the numbers are a little bit bigger. You will end up getting 750 over 1.5, which equals 500. Now, when you're working with word problems, remember that 500 is not a completely acceptable answer. So we're going to say it's 500 degrees Fahrenheit per hour. And those ovens that do ceramic pottery, they really get hot. And we can see that by the amount of the temperature changes in the hour and a half. By the way, I put per hours, but per hour is much better. Better grammar. So then if you look at this, I want you to try part B. See if you could figure out when the time interval showed the least rate of change. And just like the steeper the line, the higher the rate of change, the flatter the line, the lower the rate of change. So the lowest rate of change is going to occur up at this part I've circled in yellow, between those 2 points. That's where the line is the flattest. So you can say between 4.65 and 8.95 hours. Also, once again, I want you to find the rate of change. Go ahead and do it on your own. Pause it. So that rate of change, this one, please use a calculator if you want to. If you don't want to, that's fine with me, but I'm totally okay with you doing the calculator. It'll make it go a lot faster. However, since we're calculating it, you are going to round it. So go ahead and put approximately equal to for that part. You will get 56, and don't forget, it's in degrees Fahrenheit per hour.